Hi viewers, this is Yellesh Sir from Apex Institute of Maths and Sciences. In the previous session, we have discussed about gravitation related to some part of the worksheet. So let us discuss the remaining questions of this gravitation. So the 25th question, a satellite is in elliptical orbit about the earth, means it is moving in the elliptical orbit around the earth, and we are considering the radius of the earth is 6400 kilometers. At perigee, it has an altitude of 1100 kilometers, and at the apogee, its at altitude is 4100 kilometers. The major axis of the orbit is, so what is the major axis of the orbit? So let us see here, given the perigee, which is of 1100 kilometers, and apogee is 4100 kilometers. So he is asking us, let us consider this is the sun and it is the orbit in which it is moving. So according to the formula, the major axis is taken as a 2a, and it is equal to S1e plus 2r plus S2e2, where S1e is taken as a perigee and S2e is taken as a apogee. So by multiplying the values, 1100 plus 2 into 6400 plus 4100. So the total value will be 18,000 kilometers. So the major axis is 18,000 kilometers. So option D is the correct answer. Let's go for the next question. Gravitational force between 2-point masses where small m and capital M separated by a distance r is F. Now, if the point mass 3m is placed next to mass small m, what will be the total force on mass capital M? So here he is telling that there are two forces which we are considering. Let us take here mass m1, mass small m and capital M, and the separated distance is r, and force is taken as a F. If we are placing one more mass called 3m at the point of small m, what will be the total force on capital M? Means if you take this is a small m, mass small m, and if you consider this is a mass capital M, and the distance between them is taken as a r, and force acted is F. Now what will be the force on this mass if one more object, that is one more mass 3m, is placed near to this mass? So let us see. So this, if you consider, according to the formula, the gravitational force between the two bodies, F is equal to m1 m2 by r square. So if you take the formula, the gravitational force F is equal to G into capital M into small m by r square. So this is considered for, and already we know that the gravitational force between the 2-point masses is independent. So its point of mass 3m is placed. Then if you take the same formula, F is equal to G into capital M into small m by r square, where at m we are adding 3m mass. So finally it will become G into capital M into 3m plus m. Then it will become as 4gm into m by r square, where we know that already F is equal to G into capital M small m by r square. So substituting this f here, we get 4m. So when 3m mass is placed at m, then totally it will become as a 4m. So the total force will become as what? 4m. That is 4 times of the force, that is 4m. Next, coming to multi-correct answer type. As already till now what we discussed is a single correct answer type, means where only one answer is taken into consideration. Here in the case of multi-correct answer type, there is a possibility to have more than one answers correct. So depending upon the question, we have to choose all the options which are required. Sorry. So here the edges of the blades and knives are made sharp too. So if you see any knives or blades, one side they will have a sharp edge and the other side it may be blunt. So why that sharp edge is made? For due to making this edges sharp, what is the advantage or what are the applications we notice? So first thing, increasing the effective surface area, decreases the effective surface area, increases effective on the pressure and decreases the total thrust. So here what are the considerable answers? So first, when the blades are sharp, you will notice that decreases effective surface area, means the area is very less. That's why what happens, effective surface area is less. Next, due to the decreasing in the surface area is less, we know that the pressure increases. That is increasing the effect of the pressure. When these edges are sharp, then there will be two things which we notice. One is decreasing the effective surface area, and next, as the area decreases, the pressure increases. So increasing the effect of pressure. Okay, go for the next question. In the case of an orbiting satellite, if the radius of the orbit is decreased, so what is asking here? If you take this is a Earth and this is the orbiting satellite, in case if this radius is decreased, then what will be the effect? So if the radius is decreased, we see that the effect, its mechanical energy also decreases and its potential energy also decreases. When the satellite's orbit is reduced, automatically these both the things will be decreased. Next, which of the following statements are true for a particle on the surface of the earth? Means in the given statements, which statements are correct? Let us check one by one. First one is asking us the linear speed in minimum at the poles. So the linear speed is minimum at the poles. So the linear speed is minimum at the poles, and is asking the linear speed is maximum at the equator. The angular speed is maximum at the equator. The angular speed is 7.3 into 10 power minus 5 radians per second at the equator. So let us see which of the following statements are true. So first, the linear speed is minimum at the poles and the angular speed is given by 7.3 into 10 power minus 5 radians per second at the equator. So these are the two statements correct. Next, which of the following equations are correct? Means he has given some equations related to acceleration, related to force, and related to force of the two masses and acceleration due to gravity. So out of these equations, which of the following equations are correct? So if you observe, all the equations are correct. That is, acceleration is equal to v square by r, that is the linear momentum, and F force is equal to mv square by r, and universal gravitational force G is equal to m1 m2 by d square or r square, and acceleration due to gravity, we know that capital G into m by r square, that is G into m by r square. So all these equations are true. Next, suppose a universal gravitational constant starts to decrease, then So if the universal gravitational constant is decreasing, then what will be the effect? So the effects, if you see, length of the year will increase. Why? As the force is reduced, the time taken per may be increasing. Earth will flow a spherical path or decreases the radius. Then kinetic energy of the earth will decrease. That only we said, as the kinetic energy decreases, year will increase. So all of them are true. So we see that all these statements are true as per the universal gravitational constant. Next, which of the following statements are true? Once again, he is given some statements and is asking which statements are true. So these all are based on the gravity, acceleration due to gravity. G is 0 at the center of the earth, means it is true. So you can see that the G is 0 at the center of the earth. Next, G is maximum at the center of the earth. Generally, if you say G is 0 at the center, so we cannot say G is maximum at the center. So this will be false. Next, G decreases moving away from the center. Means as you move away from the center, the acceleration due to gravity decreases, means from the earth. Next, G is minimum at the center of the earth. So these are the options which you can see. If the earth shrinks, means it reduces to half of its radius, its mass remains same, the weight of the object on the earth will be changed by. So he is asking us, if the earth sinks to half of its radius, means if you consider this is the earth and this is the radius of the earth, then if this radius is, means if it is becoming smaller, if the earth is becoming smaller such that half of its radius, means r is becoming half of its r, then what will be the change? And see, remember, weight is same. So what will be? It change in by. What is going to change? Let us see. So here you can see the acceleration due to gravity G is inversely proportional to the radius. So G is inversely proportional to radius. So why? As already we said, G is equal to capital G into m by r square. Means this G is inversely proportional to r square. So here he is telling that mass is same and universal gravitational constant is also same. If r is decreased, automatically what happens? The G value should be increased. So if the mass is kept constant, as the mass is keeping constant, the universal gravitational constant radius is half. So this is becoming, r is becoming 1 by 2 r dash of square. So this goes for numerator. So it is increases by 4 times. So what happens? The gravity increases by 4 times. Or 4 times we can also take as root 16 times. So that both the answers are correct. The next, when your body is freely falling, as you know what the meaning of freely falling means, at a certain height, if a body is released, then we call it as a freely falling. And we know that a freely falling body will be under gravity. It experiences weightlessness, as already you know, a freely falling body has no weight, means it doesn't shows any weight, so it shows weightless. Gravitational force does not act on it. It is wrong, because due to the gravitational force only it is moving down. It will have some weight, as already said, weightlessness, so we cannot say some weight will be there. Gravitational force acts on it. So these both the statements are taken into consideration. So let us see what are the options. So it experiences the weightlessness and gravitational force acts on it. Next question. The force of attraction between the bodies is, means if you take two bodies, the force of attraction, as already we know, we have formula. What is that formula? We take generally F is equal to G into M1 M2 by R square. So with this we can tell these answers. First one, so directly proportional to the product of their masses. This one, directly proportional to the product of these masses, that is M1 into M2. Next, inversely proportional to distance between their masses is wrong. Is it clear? And inversely proportional to square of the what? Radius. So here with radius there is no, so only option C is taken into consideration. No. So next passage type questions. If we drop a body of a mass m from a height h to the surface of the earth, its speed will increase. As it comes nearer to the surface of the earth, the force on the body is equal to the product of masses and the acceleration. So this is the given statement, and based on this statement or passage, they give some questions. Let us discuss. The value of acceleration due to gravity on the earth's surface is. So as we know that the acceleration due to gravity due to earth's surface is 9.8 meters per second square. So you can see that is 9.8 meters per second square, which is constant. Next, the force is the product of masses and dash. So we know that generally we take the formula F is equal to M into A, means force is equal to mass into acceleration. So it is the product of mass into acceleration. Option D. Next, the acceleration due to gravity of a planet depends on its mass and dash. Means as you know that, so the acceleration due to gravity means G is equal to capital G into M by R square. Means this Gi value is depend upon this mass and also the radius, where G is constant. This capital G is constant, which is universal gravitational constant. So now what we can say, already he gave, depends upon mass, he said, it's okay. The next part we should take radius, that is radius. The next coming to next question, matrix match. So whenever you say matrix match, there is a possibility that one option may have only one answer, or one option may have more than one answers, or answers may be repeated to more than one question. So that's why we call it as a matrix match. Let us see one by one. Mass. So according to the given data, mass is a scalar. So what is that? Mass is a scalar quantity. Next, weight. So according to given data, what? Weight is a vector quantity. So what is the weight? Weight is a vector. So here you can take, for mass is a scalar, option C. For weight, it is a vector, option D. The next, gravitational constant. So here the meaning of gravitational constant means universal gravitational constant. And you know that universal gravitational constant is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So option A. So here you can see, and this universal gravitational constant is also a scalar. So for this we consider the options A as well as scalar C. So where we call multiple answers. And C, you see, for 39 option C is there, and also for 41 also C is there. Next, acceleration due to gravity. So here the acceleration due to gravity we know 9.8 meters per second square, and if you convert this meters into centimeters we get 980 centimeters per second square, and acceleration due to gravity have a direction towards the earth, so it is a vector. So for this you can take the considerable options 9.8, 980, and it is a vector. So what are the options we can consider here? B, D as well as E. So these are the options for this. So next, let us go for the next match. For a vertically projected body, G is, means if you are projecting a body vertically up, we know that it is moving against the gravitational force. Hence, generally we take the G value is negative. So what is that? The G value is negative. So for 43, negative is the answer. So what is the option? D. Next, for a freely falling body, same. For the freely falling body, the body is moving in the towards the gravity. So towards the gravity means it is positive. So you can see it should be positive. 44, option B is the positive. Next, relationship between small g and capital G. So small g is equal to capital G into m by r square. Already we are saying that the relationship between universal gravitational and the acceleration due to gravity. So option A. So you can see that option A. And coming to next, relationship between the period and the radius of the satellite means the time period of the satellite which is moving around the certain surface of the body, that is like Earth, and what is its radius. So it is proportional to T square is proportional to R cube. T square is proportional to R cube. So what is the option? So option C. So this is about matrix match. So next, some questions which are called as assassination and reasoning. Means one statement is taken as assassination and one more statement is taken as the reasoning. So is these are related or how they are taken into consideration? Here we have four types of options to answer this one. One is both assassination and reason are correct. The meaning is both the given A and R are correct, and R is giving explanation to support A, that is correct, and reason is the correct explanation for assassination. In the same way, both assassination and reason are correct, but reason is not the correct explanation for it. Means both the statements may be correct, but it will not support the explanation for A. Next one, assassination is correct, but the reason is wrong, incorrect. And last one, assassination is correct, but the reason may be correct. So let us see first question. When the distance between the two bodies is doubled and also the mass of each body is also doubled, the gravitational force between them remains same. So what is telling here, if you just observe, so distance between them means if you take R is the distance, so we know according to our formula F is equal to G into M1 M2 by R square. Now he is telling that R means the distance between them is doubled, means it will become as 2R. So R1 will become as 2R. The next, masses are also doubled. So M dash 1 will become as 2M1. Then M2 dash will become as 2M2. So by substituting these values, if you observe, F will be equal to G into 2m1 into 2m2 by r is becoming as 2r. So 2r whole square. Right, you observe 2 into 2 4. This will become as 4 g into m1 m2 by 2 square is 4 r square. Now if you observe 4 4 gets cancelled, the answer is g into m1 m2 by r square. So there is no change in the force. So f dash and f are becoming same. So the gravitational force remains same. So it is true. So this is true. According to the Newton's law of gravitational, force is directly proportional to the mass of the bodies and inversely proportional to the distance between them. Here he said inversely, but it is square of the distance between them. So if you observe, according to this, so this is true or is false. So association is correct, but the reason is incorrect. So next. So option C we take as consideration. So here you can see, according to the Newton's laws of motion, if the earth attracts the stone towards itself, then the stone should also attract the earth. So it is true because there is a force of attraction between the two bodies. That is F12 is equal to F21. And next, earth attracts towards the stone, but which is very small acceleration. So yes, so acceleration of the body will be less. So here both assassination reason are correct, and the reason is the correct explanation for assassination. Next, both assassination and reason are correct. For let us see the question again. The binding energy of the satellite does not depend upon the mass of the satellite, and binding energy is the negative value of the total energy of the satellite. So here if you observe, the assassination is incorrect because binding energy of a satellite does not depend upon the mass, means it depends upon the mass of the satellite, and it is total energy of the satellite is negative we take. Next, option D. Both the statements means same type but statement and statement type. The gravitational force between the two objects depends upon their masses and the distance between them. So what is telling? Gravitational force G. According to the Newton's law of gravity, the gravitational force is inversely proportional to the square of the distance between them, that the centers of two masses. So here both the statements are considered as true. Next, the acceleration due to gravity on the moon is 1/6 of that of Earth. So which is true. We know that the relationship between the gas G on moon is equal to 1/6 of G of Earth. So it is correct. Then the moon's mass is smaller and has the lower density of the Earth. So here both the statement 1 and 2 are true, but it is not explaining about the statement 1. Next, as the altitude increases, the acceleration due to gravity also increases. Means as you move higher, the G value increases. The next, gravity depends only on the mass of the Earth, not on the distance from its center. So here if you observe, here both the statements are false. Why? As you go high, as you know that G dash is G into R by R plus H. So where which is depends upon R plus H means it decreases. So what? It will be decreasing. So this is false and this is also false because it depends upon mass as well as distance. Both the statements are false. Next. At the center of the earth, the acceleration due to gravity is 0. So at the center of the earth, the acceleration due to gravity is 0. Yes, it is true. Why means the gravitational force acting from all the directions cancel out at the center. Means as the forces are acting towards the center, one force will be cancelling to the other force. So both the statements are true and it is the correct explanation. So option A. Coming to next integer type questions. Means we have a question, then we should take some solution depend upon this. Two bodies of masses 5 kgs and 10 kgs are separated by a distance of 2 meters. Find the gravitational force in 10 power minus 10 newtons. So as already you know, what here? Two bodies of masses 5 kgs and 10 kgs are separated by a distance of 2 meters. Means if you take, these are the two bodies and this is 5 kilograms and this is 10 kilograms and these are separated with 2 meters. So what is the gravitational force? So just you substitute all these values, you will get the result. Here you can see first whatever the things are given. Mass of first body is 5 kgs, mass of second body is 10 kgs and the distance between two bodies is 2 meters. Then you know that the acceleration due to gravity value 6.67 into 10 power minus 11 Newton meter square per kg square. Then these values substitute in this formula. What we have the formula, that is F is equal to G into m1 m2 by r square. So here we are substituting G value and this is m1 and m2. By multiplying you will get 5 into 10 50. By dividing this 50 and 4 you get 12.5 newtons. So now the final answer is 83.425 into 10 power minus 10 newtons. But he is asking the question 10 power minus 10. So instead of minus 11, if you want to convert into 10, we take 1 by 10 as a separate value. Then we get 8.3425 into 10 power minus 10 newtons. So what is the answer? 8.3425 into 10 power minus 10 newtons. So this is the solution. Is it clear? Next. At what height above the earth's surface does the value of gravity becomes 1/4 of its surface value? Means he is asking us at what position G dash will become 1/4 of G. At what height? Means if you take this is the earth, from this what is the height it takes. So let us see the solution. What is the radius of the earth? As already we know, the radius of the earth is taken as how much? 6,400 kilometers and the condition is 1/4 of the G should be taken. As already we said in the previously, G dash is equal to G into R by R plus H whole square. Where what should be the G value? We know that GH, if you are taking a G dash as a GH, gravity at height, G into R by R plus H whole square. Now GH is taken as 1/4 G. So this is 1/4 G, and if you take G gets cancelled. 1/4 is equal to R by R plus H whole square. So to remove this, square root on both sides. So what we'll do? Square root on both sides, that is root 1/4 is equal to square root of R by R plus H square. So here square and square root you can cancel. Then you will get 1/4 square root is 1/2. 1/2 is equal to R by R plus H, where 2R is equal to cross multiplying. We get 2R is equal to R plus H. Then R is equal to H. So at what height? From the earth's surface, if you move to again 6,400 kilometers, the G value will become 1/4. So from the earth, you should move to 6,400 kilometers. then the G value will become 1 by 4th of gravity. So that's why you can see here. So where the gravity will become 1 by 4 means at the height of 6,400 kilometers. Next, if the time period of a satellite orbiting close to the Earth's surface is 90 minutes, find the time period of a satellite orbiting at the height 4 times the Earth radius. So he is saying that if this is the first hour, and in case if this is orbiting at 4 hour, so what will be the time period? So let us see. Time period of the satellite of orbiting T1 is equal to 90 minutes, and according to our formula, the height is changed to R is changed to 4R. Then the T is equal to 2 pi under root of R cube by GM. So T1 is equal to 2 pi into R cube by GM, and T2 is equal to, here R2 is becoming R plus 4R, that is 5R. Substituting the value here, taking T2 by T1, so 2 pi gets cancelled, and here when you take GM also gets cancelled because under the same values, so 5R whole cube by R cube. When you separate, root of R cube will get cancelled, then the value is root 5 cube. So when you convert root 5 cube, we get 5 root 5. So therefore, T1 is how much? 90, because it is given 90 into 5, 450 root 5. So at what height? The time taken by the orbiting satellite is 450 root 5 minutes. And if you want to substitute, root 5 you substitute as 2.23, then we get 1006.2 minutes. Means actually it was taking 90 minutes, because of changing to 4 hour, it is taking this much time. So that's why we take the time taken to orbit will be increasing. And figure type simple. The figure shows a planet in an elliptical orbit around the sun S. So P1, P2, P3, P4 are positions. At which position of the planet will its kinetic energy is maximum? Means, as you know that if the body is close to the sun, then its kinetic energy will be more. If it is close to the sun, its kinetic energy is more. So that's where P1, where P1 is close to the position of the sun. So P1 is very close, so its kinetic energy will be more. So this end of our gravitation. Thank you.